Hello, I'm Mark Pollitt, and welcome to the Forensic Science Paradigm. It's interesting that forensic science is a relatively new science in terms of, or comparing it to other traditional sciences like chemistry and physics and that sort of thing. And because it has a relatively short history, and because, as we saw in a previous lecture, that forensic science really is a combination of traditional and non-traditional sciences, or the application of traditional sciences to non-traditional methodologies and approaches and evidence, it has somewhat lacked a foundational theoretical construct. And the best construct that I've seen came from Inman and Rudin's book, and that's what we're going to talk about in this lecture. Now, I couldn't resist this cartoon because we overuse the term paradigm, but in this particular case it actually is appropriate, and it really does fit. And in fact, Inman and Rudin used the term paradigm, so we'll use that and enjoy the cartoon. Paradigm that they describe in their book relies on the two principles, divisible matter and transfer, which we talked about in a previous video. This time we're going to talk about the four forensic processes that they describe. And we listed them last time, but now we're going to look at them in detail. The first one that they describe is identification. And according to Inman and Rudin, the originator of that is Michael Saferstein, who's written one of the, or actually a number of the core textbooks in forensic science. But he didn't actually describe it as a core process until 1998, which is not very long ago at all. And what Saferstein says that in many cases in forensic science, all we really need is to know what something is. A good example is something like drugs. We just need to know that it's cocaine or heroin or amphetamines. It may be enough to know that it was a .32 caliber bullet. If we can describe as he calls it, as Saferstein calls it, the physiochemical nature of the evidence, then that may be all we need. Now, in addition to drugs in the toxicology arena, merely identifying a poison may be enough. To know that it was strychnine may be enough to charge an individual, may be enough to diagnose what the methodology was for their murder. In the digital arena, there are relatively few things that in and of themselves the identification is sufficient. One exception to that rule is child pornography. And in many cases, digital forensic examiners will be asked to conduct examinations strictly for the purpose of identifying child pornography. So merely finding that may be sufficient for our examination purposes. But as I say, typically that's not the case. And we typically will also need to do more than merely identify it, and we'll talk about that when we get to our next classification. Which the next process that they talk about is classification and individualization. And those two things really are variations on the same theme. And before I go into the force explanation, etc., let me try to give you an example and put it into a context. If I find a dead body and I find a hole in their chest, and the pathologist does their autopsy and they remove a bullet from that body, we may be able to look at that bullet, and based on its dimensions, the length of it, the width of it, the weight of it, we may be able to say that it's consistent with a 9mm bullet. Well, actually, there's not much difference between a 9mm and a .38 special. There's really 1/1000 of an inch difference in the diameter. But in any case, we may be able to say that it's a 9mm bullet based on the shape and the size and the dimensions and the weight of it. That tells us something, but it doesn't tell us very much. It isn't enough to identify it with any particular gun. Now, we may look at the lands and grooves, which are the markings on the side of the bullet, and we may be able to determine that based on that pattern, the number of lands and grooves, the direction of them, and the rotation of the bullet, and how quickly that rotation occurs, we may be able to say that the lands and grooves and markings on the bullet are consistent with a particular manufacturer, let us say Beretta. So we can say that we're likely looking at a Beretta 9mm that fired this gun. Well, that helps, but it still doesn't get us to the particular gun in question. Now, if the investigators subsequently identify a suspect who has a 9mm Beretta gun in their possession, they can then take that gun, assuming that they've got legal authority to do so, and test fire that gun. And they can then test fire, they can then take the bullet from that test firing and compare that bullet to the bullet that was found in the individual. If the lands and grooves and the striations, the micro detail of that bullet match the bullet found in the subject, then we can say that the bullet found in that subject came from that Beretta, that particular Beretta 9mm, to the exclusion of any other gun in the world. Now, the fact that the bullet was of the same shape and size as a 9mm is what's called class evidence. There are lots of 9mm bullets out there. That doesn't tell us much. The fact that the bullet came from a Beretta 9mm is still class evidence, because there are lots of Beretta 9mm out there. But when we get to the point where we can say that that bullet came from that gun to the exclusion of all others, it then becomes individual evidence. So we classify things in ever more granularity until we can get to the point where we can identify it to the exclusion of any others, and then it becomes individual evidence. And so class evidence is less valuable than individual evidence, but it's not worthless. We may in fact be able to use class evidence in order to develop a circumstantial case, and sufficient circumstantial case may still end up proving our case in chief. So in many cases, we're going to be collecting evidence that is only class evidence. In some cases, we may be able to individualize that. So for that reason, because this is really a spectrum, Inman and Rudin typically include it as a single process. Now, DeForest says that what you're really doing is trying to identify the source of the evidence. In the case of our bullet, we're trying to identify the source, the particular gun that fired that bullet. But we may not be able to do that depending on what we have. But we may be able to compare items to determine if they originate from a common source. And so we may be able to identify that that bullet was a 9mm bullet, so it's from all of the 9mm bullets out there, but that may not be individual. And as we saw in our example, the result can either be classified or individualized. It could be class evidence or individual evidence. Now, example, fingerprints. Fingerprints, if we have a loop or a whorl, right, those are class characteristics. Lots of us have loops and whorls. But if you can take a particular loop and whorl and look at the minutiae and say that the loop and whorl from this latent fingerprint found at the scene of the crime is identical to the inked print given by the subject, then you can individualize that print. So it's no longer merely a loop or a whorl, it's Mark Pollitt's left index loop. Similarly, DNA can be class evidence or it can be individual evidence. technically, DNA is always class evidence, but with such a high level of probability that for all intents and purposes it becomes individual evidence. We never say that DNA is a match in real life. What we say is that the probability of this DNA originating from the given source is this astronomical number percentage, 1 in 26 trillion or something like that. And so technically it's all class evidence, but we treat it as individual evidence. Here is an example of what I was talking about with the bullets. In this particular case, you can see on the left-hand side here where we have the perhaps known bullet, and this is the question bullet, the one that was found from the subject. You can see how the microstriae all match along here, and so a trained firearms examiner would say that these have a common source, and therefore it can individualize this bullet as having come from the same source as this bullet. Similarly, the cartridge casing, you can see the primer cup here is a known and an unknown, and you can see that the microstriae on these match up exactly. Also, you can see that the firing pin is off center slightly, and you can see that it actually creates a little angle as it goes in, and so these are in fact matches. Now, one of the things that we typically try to do is we try to associate a piece of evidence to a particular person or a particular location. And what we're trying to do is, Osterberg said, connect a person to a crime scene. And this typically relies on Locard's theory of exchange, because the idea is the transference from one object to another object can occur in either one or two directions. And so you have this combination of materials, something gained, something lost. And it almost always is class evidence, but the probability of a particular set of evidence occurring in a particular place can be extremely probative. Now, it's probably easier if I give an example. And the classic case is the Wayne Williams homicide cases in Atlanta. Wayne Williams was a subject that ultimately was convicted of kidnapping and sexually molesting and then killing a number of teenage young men. These young men were typically found in a river near Atlanta, and until as they did the exams, they were able to collect class evidence, but nothing that would help them identify a subject. Eventually, they developed Wayne Williams as a subject and conducted a search warrant of his car and his house. And they found a number of textile things there. They found, of course, the inside of his trunk had some fibers from the liner. There was a blanket located, I think, in his trunk, and he also had carpet in his home. And when they looked at the remains of the victims and their clothing, they were able to find fibers that were consistent with the fibers on his carpet, the fibers on that blanket, and the fibers in the trunk of his car. Now, in and of themselves, each of those are merely class evidence. But ultimately, the jury was asked, what is the chances of these three particular fibers all showing up on these victims and occurring in Wayne Williams' house, car, and blanket, respectively? And the probability was extremely low that it was anyone other than him, and in the end, the jury convicted him. We see similar things to these fiber analysis with soil. Soils are actually made up of a number of different chemicals in different sizes and shapes and formations, and so the combination of these it can be extremely unique down to a very small geographical area. Glass, interestingly enough, has a lot of interesting characteristics which allow them to be examined often for association. And paint, of course, is extremely useful for determining association. So each of these different kinds of evidence can be used to associate one person to another. In the digital forensic arena, association is very commonly done through the connection of networks and emails and those sorts of things, but can also be done by the possession of files in common. Obviously, something like Microsoft Word as a particular executable application is not terribly unique. But if I find exactly the same file or file remnant of a Word document on my computer and someone else's computer, then the question arises, how did those two things happen to both be there, and what is the association between those two? So that's association, and another one of the examples. And here we see some fiber examples. You can see that there are differences between wool and cotton and flax, and they also have different colors, and we can measure these colors, and we can measure them down to a very fine degree, so that what looks like the same color to our eye using a photospectrograph can be very different, and it's amazing the things that they can do with fiber evidence. The last process that Inman and Rudin discuss is the notion of reconstruction. And if you think about it, that's really what pathologists do. In addition to identifying what particularly killed somebody, the cause of death, what their even larger job is the job of reconstructing the manner of death. So you may have died of suffocation, you may have died from a loss of blood, but the question is, how did you come to suffocate, or how did you come to bleed to death? And understanding these sequences of events is what we call reconstruction. And it's also described as ordering associations in time and space. How do we get these things together so that they produce the end result? They answer typically the when, where, and how questions from the who, what, when, where, how, and why. And we commonly use them in traditional forensic science in things like trajectories for bullets, or blood splatter analysis, and certainly forensic pathology. We also use it very commonly in digital evidence if we're trying to identify malware and how malware operates. We typically do reconstructions in computer hacking cases, intrusion cases. We very often will do them in fraud cases when we're trying to identify how things were changed and how things were printed and that sort of thing. So reconstruction is something that we very commonly do in digital evidence. We just have some very different tools to do it with. So these are these four characteristics. So the first question is, which of the four processes is used in digital evidence? And I think we've already answered that as we've gone along. They're all used. But merely knowing that they're used is not enough, because as we learn how to design our examinations, we need to think about what are we trying to accomplish. And Inman and Rudin's point is that fundamentally, when we do forensic examinations, we're trying to accomplish one or more of these specific forensic processes. And so as you develop your examinations, we're going to have you actually decide up front and articulate in your report what forensic questions you're answering by doing these particular examinations. Or what forensic questions do I need to ask, and so what tools am I then going to use to answer those forensic questions? So it's really important for you to understand these things. You'll probably want to look at these slides and maybe this video again as you proceed along in this course. Well, as always, I thank you for your time and attention. And until next time, have a good day.